right, so P is the initial, so that's $1,200. E is always E. R is your rate. Don't forget to turn that into a decimal by moving it 2 places. T is your variable because we're figuring out how long it is. Now it wants to know how long it will take for it to double. And that's 2,400. We'll talk about that as well in a second. All right, so recall from solving equations, which we've done the last couple days. Basically, what we want to do is we want to isolate this. And to isolate that, we're going to divide both sides by 1,200. And we end up with 2. So 2 equals e to the 0.0132. All right, whenever a problem asks you to double, ladies and gentlemen, you can go right to that if you'd like. You don't need to set up with the 2,400 and 1,200. Because whenever it doubles and we divide, we're always going to get back to 2. If it asks you to triple, 3. Okay? So there you go. So 2 equals e to the 0.013t. We now have that isolated, so we do the natural log of both sides. So the natural log of 2 equals the natural log of e to the 0.013t. The natural log and the e cancel out, leaving us with whatever the variable expression is. So the natural log of 2 equals 0.013t. To get rid of a multiplication by 0.013, we would divide both sides by 0.013. Beginning Monday, by the way, these calculators will be out. I just ask you to leave them out when you're done so that they can be disinfected. Okay? So I'm going to divide natural log of 2. Okay? If you are going to try to do it all in one step, please make sure you close the parentheses when you do a natural log. Divided by 0.013. And you get 53.319. All right, we're going to assume they're asking for an integer value, so we're going to say approximately 54 years. All right. So there's no difference between what you've been doing all week and this. You're just applying it to word problems. You will always be given the equation or enough information to do that. Carlos has taken an additional dose of a prescription medication. The relationship between the elapsed time t and hours since he first took the dose and the amount of medication, milligrams, in his bloodstream is modeled by the function m of t equals 20 times e to the negative 0.82. And how many hours will Carlos have 1 milligram of medication remaining in his bloodstream? Round your answer if necessary to the nearest hundredths. Okay, now we did this problem previously, but we evaluated how much is after time. Now we're going to work backwards. So we want to know when he'll have 1 milligram. We're going to assume we're starting with 20. All right, so all we're going to do is take the equation and set it equal to 1, the desired amount. Okay. So 1 equals 20 times e to the negative 0.8t. All right. Divide by 20, we get the decimal 0.05 equals e to the negative 0.8t. We will do the natural log of both sides. That will get rid of the e, and our equation will just be negative 0.8t. All right, I'm then going to do the natural log of 0.05. For those that want to do it separately, that comes out to about negative 2.996 when we go to the nearest thousandths, equals negative 0.8t, which is good because we want them both to be negatives. And then to get rid of the multiplication by negative 0.8, we divide by negative 0.8. Cancels that out. And approximately 3 3/4 hours. That's about 3.74. All right, do me a favor and set yourself up with an equation using percent and work from there. Your labor company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest the trees? Everybody remember that? 1 plus minus r to the t. That's generic for the when it's not a specific type of thing. All right. So we're talking about 1,200,000 trees. All right. And our goal is 0. $1,200,000 is the initial. All right. And if we're harvesting 7% of the trees each year, is it going up or going down? Going down. So we're going to subtract, so 0.93 to the 2. Here's our problem. All right. We divide by the 1.2 million. We still have 0 equals 0.93 to the 2. Since that's an exponent with a base 0.93, I'm going to do the log of that base, 0.93. 0 equals the log base 0.93, 0.932. This cannot be done. This cannot be done. All right. So my suggestion is if you get a problem like this, instead of making that 0, make it 1. All right. All right. So 1 over 1,200,000 equals 0.932. If you try to do it as a decimal, the calculator is going to give you it in scientific notation. So I would leave it as a fraction. All right, now at least it's not 0. So now the log 0.93 of 1 over 1,200,000 equals log 0.93 of 0.93 to the t. All right. On the right-hand side, of course, it will cancel out. If I go to my calculator and do the log 0.93 of 1 over 1.2 million, I would start by putting in the 1,200,000. Like I said, it'll give it to you in scientific notation, but it's not a big deal. All right. So we're doing the log of 0.93 of 8.3 times 10 to the negative 7. All right, remember change base becomes the log of 8.3 times 10 to the negative 7 over the log 0.93. Log of the number divided by the log of the base. I go back to my calculator, log 1 divided by that. You're going to give me that number. I divide that by 8.3. Inside the log of 0.93. And I get 192 years. All right, so don't make it equal to 0, make it equal to 1 to avoid that situation. All right, a cable company with a reputation for poor customer service is losing subscribers at a rate of approximately 3% per year. The owner believes that when the company is down to 1.2 million customers, it will begin to lose money. How many years does the owner have until she should sell the company to avoid losing money? All right. Problem is we don't know how many subscribers there are in the beginning, so we will make that 2 million even. So we'll say there's 2 million currently. All right. If you want to make your numbers smaller, you don't necessarily have to write out the millions. It's not going to affect the problem. All right. So 1.25 is what we were looking for the final goal. All right. The initial can be the 2. If we're losing 3% per year, we subtract 0.97 to the t. Again, we want to isolate the exponential part first, so we got to get rid of a division multiplication by 2. To do that, I divide 0.625 equals 0.97 to the t. Okay. When I do the log of the base, which is 0.97 to both sides, it will cancel out the 0.97. So I'm doing the log 0.97 of 0.625 equals t. That's to help you tonight if it wants exact solutions. And then I'm going to use the change of base. So I'm going to do the log of 0.625 divided by the log of 0.97. And according to my calculations, it will come out to be about 15.4 years. All right. Yes, ma'am. We got to just establish it. So it didn't have the number in there. So when I obviously stole this from somebody else, I forgot to look this either. How's that for honesty? All right. We'll do one more. We'll leave the Half-Life one for Monday. All right. 5 years ago, Mr. Fitzsimmons bought a laptop for $2,300. Every year, the value of the laptop decreases by 11%. When will the laptop only be worth $1,000? All right. So you got to be careful. They're adding different years. So 5 years ago. All right. So that would be 2016. Mr. Fitzsimmons bought a laptop for $2,300. Every year, the value of the laptop decreases by 11%. When will the laptop only be worth $1,000? So that's our final. So that's going to be isolated all by itself. All right. Equals the initial $2,300. Again, it's going down, so it decreases by 11%, so that'd be 0.89 to the T. Divide by the 2,300. Again, if it makes your life easier, the zeros are going to cancel out, but that's up to you. You don't have to do that. The base of my exponent is 0.89, so the base of my log is going to be 0.89. So the log 0.89 of 10 over 23 equals T. All right, again, you don't have to do those shortcuts. You can write it out if you want. I go to my calculator. I can enter 1023 as a fraction if I want. So the log of 10 divided by 23 gives me that. Divided by the log 0.89 gives me that. And we got about 7.147. All right. But remember, they bought it 5 years ago. So we don't add 7 to the current year. We add it to what year? 2016. So that would make it 2023, somewhere in that year, a little more than that. So that type of problem, assume they bought it on January 1st. So if it's 7.14 but less than 8, it's still going to be 2023. Got me? You kind of round down. Good. All right, got about 20 minutes to finish up those 2 assignments that are due tonight. If you're already done with that, you have 20 minutes to think about how the world's a better place with you. It is. Better place for all of us. It's a better place with all of us. We all bring something to the table. I bring blue love. You guys can go if you're good to go. Have yourself a one. Oh, I'm looking at the wrong thing. Oops, there goes my water bottle. I'm looking at the wrong thing. All right, let me go backwards. Sorry. You guys are good to go if you want to go. Have yourself a great weekend. Don't forget to submit your homework tonight unless you have questions. Feel free to stay along and I'll answer them when you get here.
Thank you.
Have a good day.
Ask you anything with that. That is the ones that are due on Monday or tonight. There's 2 things due tonight if you go and you look. All right, so in classwork, all right. Week of February 5th to 19th. You already asked your one question. We had this discussion. You had one question. I gave it to you. Oh, boy. All right. So you have, give me a second. All right. So this is the 3.4 homework that's due tonight. That's the one with a bunch of problems. Okay. So that's the one that goes through 33. What? The other one that's due tomorrow? Give me 1 second. So this one's due tonight. Tomorrow, 12:01. If you get it within like an hour or so, I'm usually good. Okay? I'm a night person. I don't know what to say. All right. The other one you have is this one. It's not long. It's 6 problems. No, I don't. I posted it up there. What the heck? I can make copies once I'm done with Abigail's second question of the day, which is illegal because I told her one. Better if there's a who, what, when, where, why, shut me down. Oh, no, sorry, you got to be in school. No, I'm not believing in that. You're in school to learn. This is not school. That is performance. I don't know. This is shady. School. What? Yes, I've been fighting those people for years. Gas already 3/4 out the door, brother. I gotta go make copies. I'll be right back. Anybody else need anything while I make copies for people? I just gotta make a copy. You need a copy of it? If there's anything in the hallway, would you like me to bring my steering device? Let's see if I can get grandma some grub. You both need it, right? How many other people need this? So let's do tonight. Okay. So I don't trust Capelli because I messed with him, so I'm gonna switch user. Hey.
Abby, you read? You read?
I read it in full. And then, wait, what was it? Did you? Oh, you want, question up.
5, 8.
Oh, really? Oh. It's one day. One day, I was just having a relaxing. We spoke for one day.
I walk her.
I've never met a good
Let's say a day.
Stop. Oh my god. It sounds like psychology.
She would have done
I said, Danny literally looked like he walked into his closet, went like this, and just, or whatever, he was like, I'm confused. We were walking down the hallway, and I was like, I look like someone's grandma. I think it was someone's dead grandma. I lost my, because he had his hand up, and I just looked at him, I was like, and he just went, I started. I don't know. I just handed in my first year, so I'll just find my for the past 2 weeks. I'm missing like 7 things in that class. I'm gonna walk into M3 and I'm just like get killed on the spot. Yeah. I just like I haven't done it anywhere in any class. I'm so done. I wanted to do something.
you right, like,
Yeah, I still have to learn financial literacy.
usually I just like pick the same Friday, Sunday the same Friday. You ever like circle like read on them? I still if you wrote like a banger and you wanted to read it. You can like circle like read it. Yeah, it's yeah. I circle like read on some so that you know. We should. No, yeah. And wear the same pants, same shirt.
Oh, I remember. And he's like, you know what, okay.
Yeah.
This is the whole. This is the second half of the whole number is this, that we don't have. So that brought over in class yesterday. No? Yeah. This is how I never know that. I swear to God, no, it's just the second.
That's what we did in class. That's what we did during last week. All this. We did all this during, that's what we did yesterday during last week.
Oh, wait, I know, I think it's. It's literally the first period. I didn't know that, please. What do you mean, what I mean? Wait a minute.